Welcome to EDU World Space.
Okay, so for the first question, we know sine theta c is equal to ng over nw. So theta c here is the critical angle. Ng is the index of refraction of gas, which is the one we are looking for to determine in this question. And nw is the index of refraction in water. So therefore, we have ng is equal to nw sine theta c. And we know the critical angle can be equal to the move distance divided by the radius, which is 1.09 meter over 2.20 meter over 2, since the diameter is given as 2.20 meter. So therefore, the radius is half diameter, which is 2.20 meter divided by 2. So eventually we have theta c is equal to 0.99 radians. If we convert it to angles, it's about 56.8 degree. So we know the index of refraction in water is 1.33. So therefore, we can determine the index of refraction in a gas, which is Ng is equal to 1.33 times sine 56.8 degree, which is equal to 1.11. And for the next question, well, there are two sub-questions. So first sub-question. So when the move distance is greater than 1.09 meter, the time should be equal to 2t1, which is 2 times nw times r over c. Okay? Because when s is greater than 1.09 meter, the angle of incidence is greater than the critical angle. Okay? And the t1 here is the time taken by the light to reach the center from the laser, which is nw r over c. So nw is the index of refraction in water, and r is the radius, and c is the speed of light. So therefore, let's try and determine the time. So the time should be equal to 2 times 1.33, and then times 1.10 meter over 3 times 10 to the power of negative 8. No, sorry, positive 8. 10 to the power of 8 meter per second. And this will give us the time, the minimum time is about 9.75 times 10 to the power of negative 9 seconds, which is 9.75 nanoseconds. And for the second sub question, so S is less than 1.09 meter, okay? Which means that the angle is less than critical angle. So the ray undergoes refraction through the gas media, okay? So therefore we have T is equal to T1 plus T2, which is NWR over C plus NGR over C. If we do some arrangement here, we have R over C times NW plus NG. We know R, which is the radius, is 1.10 meter, and C is the speed of light. NW is the index of refraction in water, which is 1.33, and NG is the index of refraction in a gas, which is 1.11. So now let's determine the minimum time in this case, which is equal to 1.10 meter over 3 times 10 to the power of 8 meter per second, and then times 1.33 plus 1.11, and this will give us the times about 8.95 times 10 to the power of negative 9 second, which is 8.95 nanoseconds. And these are the answers for this